says like R1.
Don't worry, Mitch, we didn't forget about you. Alright, so we're learning about polar graphing. And she's telling us how to enter it on a calculator.
Alright, ready? So you're going to see R of theta. In rectangular graphing, which is the old way, all of your points are x comma y, right? Well, in polar, now all of our points are r comma theta.
Ew.
It completely changes the way you do graphs. You're still graphing on the coordinate plane, even though like this is the polar board. I never use it. It's really dumb and annoying and total waste. Because you're still on the rectangular like XY axis when you're graphing stuff. You just graph a little bit of a different way. So just for fun, let's put in some stuff. Everything's going to be trig, or most stuff is going to be trig.
We should put this on the corner here, Dan.
Like just sine. Let's put in sine theta plus cosine theta. Let's see what we get.
How do you add a theta?
Theta. I wonder if you put a pi button. Here. Where is theta?
Separate.
It really is.
Is that it? That
Okay,
thing
where's
with the
the
line
pi
through the
button?
middle?
It's on the bottom left.
Oh, got it.
I don't know if that's theta.
Want to be fourth?
When have we ever?
Well, usually Danny's there.
Do you have an Inspire or 84? You just change it. Go to, there's a trig button next to equals.
No, it's not.
And that'll give you all your
I
stuff.
haven't seen this one. Between like.
Oh, it's kind of boring actually. It's just a circle. It's not very exciting, but it's a circle. Let's make it more exciting. Let's put a 2 in front of the sign and see what happens.
So it's gonna be r comma theta equals something?
No, it's going to be r equals something.
Oh, okay. But it's gonna, so it's like x, y.
Exactly. I'll actually do that in a second. Go put a 2 in front of your sign and see if that changes anything.
Oh, the circle's a little bigger now.
Is that all it did?
Yeah.
What if we put like a circle?
It's supposed to be like a little circle. You did get a circle. You did get a circle. Yeah, okay. The 2 just made it bigger. That's so boring.
Wait, are we in
Radians. Okay, alright, fine. Go back. Instead of doing this, let's do this. Do r sub theta equals theta.
Oh wait, I don't have to be writing this down. R sub theta equals theta. That's what that comma means, sub.
Yeah.
Whoa! That was cool. That was interesting. I don't want to graph this, by the way.
Ooh, that's.
Oh, really cute.
Yes.
Yeah, that's what I just showed you.
Alright, so now you got part of a little squirrely thing. Go to your window. So press menu and go down to number 4, window. And go to window settings. And you have an X-min and an X-max and a Y-min and a Y-max. Is that all you have?
What are we doing here?
I wanted to change the polar thing. God, I hate
that.
What are we doing?
I don't know. Wait, how'd you get that? Typed in R.
Theta equals theta. Theta's right here.
Alright, whatever. I don't know how to work my calculator yet. So, you can put in all kinds of stuff, and you can get all kinds of crazy squirrels. But here's where this stuff comes from. So first of all, it's not pointless. There's a question about what the heck this means. Why do I have r sub 1 of theta? This is like the same thing as saying f of x. Like, it's the same thing, it's like the r with respect to theta. Don't let that get you confused. Our functions are just going to look like this. Instead of y equals 3x, it's going to be like r equals sine theta. So those are just 2 examples of what an equation could look like. So the calculator is really not going to help us yet until we know a little bit more, but here's what you need to know first. You need to know how to plot a point. So just like when you started doing rectangular stuff and you were like, okay, the point 2, 3 is here, you need to know how to graph a polar point. So the R stands for a radius, and the theta stands for an angle. Most of the time we'll be in radians. You'll know, because if it says 60, you can usually guarantee that means degrees, but if it said pi over 3, you can guarantee that means radians. So here's how you graph it. Even though the order goes r comma theta, you actually start with the theta measurement. And let's say we want to graph the point 2 comma pi over 3. The first thing you're going to do is move to the angle of pi over 3. So like angles always start here, and I know that pi over 3 is up here. And then I'm just going to move 2 in the positive direction away from the origin.
Along the angle?
Along the angle.
Wait,
so for example, if pi over 3, if that angle would be here, like I don't draw it actually, I move away from the origin 1, 2 units away, following that like angle line.
So basically
And that's
this is
where that
just
point would go.
total freehand.
Yeah.
Wow. I don't know how far 2 is though.
Exactly.
You make it up. Just like you know how far is 1 when you're doing this, you just put little marks. So whatever you define 2 to be, there's 2.
So there is no like x and y axis.
This is still the x-axis and this is still the y-axis, but the polar point 2 comma pi over 3 goes there. So it also has x and y coordinates that go with it. We'll get to that in just a second. It's so fun.
So basically it looks like that thing goes back.
No, because there's x and y.
So like I could have used this to graph like pi over 3 and we got 1, 2, and ended up there.
Except the fact all these are just the numbers far out.
Yeah, no, what?
You just accept the fact that it's graphed the way the calculator graphs it.
No, that would be so terrible.
I
So, like,
accept it.
So let's say this is point A.
Yeah.
Let's say point B.
Nah.
And let's graph something at 4 comma 3 pi over 2.
That's a lot of work.
So you're going to figure out where is 3 pi over 2. And then from wherever that angle ends, I'm going to count 3 away from the origin. 1, 2, 3. And I'll try to keep my measuring like consistent.
Isn't it
Oh,
4?
4. Sorry.
Way to go.
Here. So there's point B. Okay. Now,
that's
what if I
also-
said point C is going to be at negative 3, comma 5 pi over 6? You're still going to go to the angle of 5 pi over 6,
You go the other way.
which is like here. But instead of counting out 3 in that direction, I'm going to go 3 in the opposite direction. 1, 2, 3. So I'm always going to go to wherever that angle tells me to go, 5 pi over 6. This is that angle, and it goes in both directions. That angle goes this way, but also if I continued, it would go this way. And if I'm going to move in the way this wants me to move, I'm going to go negative. So I'm going to move away from that angle 3.
So if they were both negative.
But they were both negative, so if I had point D, say negative 2, negative pi over 4. First, they're separate from each other. So first I'm going to find negative pi over 4. So negative pi over 4, go this way. It's like here. And I'm supposed to move negative 2. So instead of being here close to C, I'm moving the other direction. Did I make that? So there's point D. Now, not yet. But if I had to graph something like r equals the sine of theta, I mean that's a polar graph, I can use a t-chart with r's and thetas and figure out where all my points are and connect them, and that's what gives me the graph. So we'll move into that, but not quite yet. But that's going to be the connection, just like with rectangular stuff. First you learn how to plot a point, move over and up, over and up. And then we learned that when you have this, if I make a T-chart of all those points and connect them, that gives me the graph. So it's the same thing. If you had learned polar first, you'd think rectangular was weird. But you learned rectangular first, so you think polar is weird. All right, how about this? Just tell me, don't even write it down. In what quadrant is the point -6, 7 pi over 6? Don't shout it out, just think for a second. In what quadrant is the point -6, 7 pi over 6?
Yeah, can we hold up?
Sure, you can hold up the number.
Hold on.
Back? I'm seeing a lot of 1s, and that's good, but the 2s are wrong. No.
Yeah, what?
Wait. No, it's quadrant 1, right?
Yeah.
Yeah. Yeah. Because 7 pi over 6 brings me here, and 6 moves in a negative direction. Oh. Alright, how about this one? In what quadrant is 3 negative 3 pi over, no.
I don't know.
Alright, in what quadrant is 3, negative pi over 4?
No, Florida. No, I didn't.
Yeah,
4, yeah. I was agreeing with Matt and said 2. Through me.
I was thinking about it. But
Oh, yeah.
I was
4. Okay, is that alright? Okay, we're not done. Don't worry. Okay, so all of these points have a rectangular partner. For example, if I had the point, let me think for a second, 1, pi over 4. What's the rectangular coordinate of that point? If this is polar, and I'm at pi over 4, 1, where is that? It's not 1, 1.
No, it's 1.25.
Yeah. Like 1 and then.
This is a really good question.
Ooh, is it? It's point. Square root of 2 over 2. Square root of 2 over 2.
Yes! It's root 2 over 2 root 2 over 2.
Why?
Because if I have a radius of 1, I'm really on the unit circle. And the angle's pi over 4. So what's the coordinate there? It's that. Oh, mind's blown.
I don't like that. What's that?
There's other ones that work too, right? If I have the polar coordinate 1 and pi over 3, what's the rectangular coordinate for that?
Root 3 over 2, 1
I think it's the other, pi over 3 is going to be up here. 1/2 root 3 over 2. So that's how these kind of correspond. That's interesting, right? Yeah.
But do all of them work?
But this only works if the radius is 1, and if I gave you an angle that we know. So if it's not one of the places on the circle that you know, this doesn't help you. So we need some other way to connect it.
What about the 4, 3 pi over 2?
4, 3 pi over 2. That you can, yeah. Okay, so yeah, good point. If I had 4, 3 pi over 2, what's the rectangular thing from that?
0 negative.
3 pi over 2 puts me here. 1, 2, oops, whatever. 1, 2, 3, 4 puts me down here. 0, negative 4, right? I have a sneeze coming.
Let's hear.
What?
Oh my god.
Oh my gosh, that was.
God bless you.
I never do, actually. I'm not sick.
This loud sound and all the air goes into your vocal cords instead
It
of
would
your
be.
sinus.
I would infect myself. I'd much rather get that side of the room sick. Just kidding. Okay, so what's the connection?
She's trying to get us sick, pretty much. What she's trying to say here.
Everything goes back to a triangle.
That's my least favorite shape.
I hate trigging.
Connecting.
Right there with you.
I don't understand. Can we not? I don't
Okay.
understand what this is.
If we want to like connect the two, keep in mind, x's and y's are rectangular. R's and thetas are polar, but they are friends. And this is how they're connected. What do you think I'm going to call that angle down there? Theta. What do you think I'm going to call this side of the triangle?
A.
I'll call it x because it's horizontal. What do you think I'll call this side? Y. What do you think I'm going to call this? R. It's a radius. So everything is connected. So we know a couple of things. I want some formulas that are going to like connect x's and y's to r's and thetas.
X squared plus y squared.
One of them, is that x squared plus y squared is going to equal r squared all the time.
And then
And that's kind of where some of this came from. If you go take x squared plus y squared, you should always get r squared. So like, let me use a different color. What's root 2 over 2 squared? A number 1 half, right? Plus 1 half gets me 1. Good. That should work for all of them. So this square, this is 1/4, plus this is 3/4. Adam got me to 1. Okay, so x squared plus y squared should always equal r squared. Good. What else do we know?
doesn't tangent of the angle equals y over x?
We know that the tangent of theta equals y over x from SOHCAHTOA. This is a good one, and then we also know that the sine of theta equals y over r, and that the cosine of theta equals x over r. These are really helpful because I can actually say from this that y equals r sine theta. The first time I did polar, I swear to you, I don't remember ever doing it in high school. I'm sure I did, and I was, I don't know, playing footsies at the time. Or writing notes to my friends because we didn't have phones like you fancy pants. But I swear I did not learn this. I'm sure I did. So when I went to teach it again, because it's not like I learned it in college again because I was like past it, I got so like bogged down with these formulas because I thought I had to memorize them. But hopefully you'll understand, like, this is where they come from. They come from this easy triangle. So remember them that way. If y equals r sine theta, what does x equal? R cosine theta. So,
I'm too excited for Disney.
you're not going.
Or am I?
Tina's going.
I know, I'm so happy for her.
To learn.
I'm so
We're
happy.
all so happy for Tina.
Yeah. So, if I was given,
Why did you? What just happened there?
what happened is you guys were looking at a piece of paper, you missed what I was doing. That's what happened.
Yeah, he stole it.
Okay.
Nice detailed picture.
So anyway, if I were given a polar coordinate like this, and I was asked to find its, oh my gosh, seriously?
We're too excited for Disney.
And I was asked to find its rectangular buddy, I could use this stuff to find the x and find the y. So let's just do one with one we know. If I was given, oh my gosh, the polar coordinate of 1 pi over 3, and I had to find the rectangular, I'd be like, all right, well, I know the x is going to be r times the cosine of theta. Okay, seriously, you need to stop, okay? If you need to be bored, like, put your head down, it's fine, but it's just too distracting. It's not fair. So if I have a polar coordinate, and this is one that I know, and I want to find out what the x is and what the y is, so, like, I already know this one, but if I didn't know it, x would equal r times the cosine of theta. So if this is the polar one, first thing's r, the second thing's theta. The x value would be 1 times the cosine of pi over 3. So the x coordinate would be the cosine of pi over 3, which we already know is 1/2. We already got that. So this is going to be the way to find it, no matter where it is. So when we were making this connection over here, this was like, we already knew this, because I gave you the radius of 1. It was really easy. Everything was on the unit circle. But now it's not going to be. So now you can find any polar point that you're given. Well, if you have a calculator, you can find what goes with it. So for example, let's say I have, let's make the radius something we aren't good at. So like, let's make the radius 3, but let's still make this like pi over 4. Because otherwise you're going to need your calculator. If you get a polar angle, it's not one of the ones on the unit circle, you need the calculator for it. So if you're given that polar point, and you graph it, and you're like, all right, pi over 4, 3 away, here it is, floating around in space. You might want to know like how far over and how high up, like where is it in the xy world? So this is 3 comma pi over 4. Well, to find out where it is, x is just going to equal r times cosine of theta. So x is going to equal, the r is 3, and the cosine of theta is cosine of that. What's cosine of pi over 4? Root 2 over 2. So we're going to have 3 root 2 over 2. So this same point, here's polar. The rectangular coordinates are 3 root 2 over 2, which really is not very useful. 3 times root 2 over 2. Is that number like bigger than 1 or less than 1?
Bigger.
Bigger? Is it bigger than 2 or less than 2?
Bigger.
Root 2
I don't know.
is 3
Three halves.
1.
It's bigger than 3 halves.
It's bigger than 3 halves. It's bigger than 3 halves, but it's not.
But it's smaller than 2, right?
Yeah, bigger than 3 halves, smaller than 2.
Yeah.
So it's in between 1.5 and 2.
It's some decimal, 1 point something.
1.7.
There you go. And then the y coordinate is going to be 3 times the cosine. I mean, sorry. It's 2 point something?
2.12.
Really? Interesting.
And it's going to give you the same spot. Isn't that exciting? So for today, I just want you to be comfortable with how to graph something that's polar, just the coordinates, like how to graph, the r and the theta, and then how to take a polar coordinate and write it as rectangular. Is that okay? Let's just stop. We'll do a little bit more tomorrow. And then we'll be done. We won't be done. But we'll be done.
We'll be done for the week.
Yeah.
Do we have homework? Do we have homework?
Yes.